So today I want to introduce everybody to learn how to read a Metar or decode a Metar. So first I want to teach everybody how to get access to the Metar itself. So we're going to open up Google and we're going to type in Nav Canada Metar. And then the next page we'll see is the Metar and TAF selection page. And what we're going to do is click on that link there. And once we click on that link, we'll be open to this page here where we can enter an aerodrome ID. So in this case, it gives you an example. You can enter Montreal, Toronto, Pearson, or Vancouver International. And once we put that in, we can type in, for example, in this case, I use Toronto. So for the select and output format, in this case, we're going to choose standard because we're going to learn how to practice decoding. But if you want to practice at home by yourself, you can choose plain language to learn how to read each part and see how they associate with each other. And finally, you hit get the bulletins and you'll be open to this page here. So with this Metar, I'm just going to quickly read it out. And then later on, we're going to explain each part by part. So for this case, it's a Metar at Toronto Pearson Airport. It's on the 24th day at 2100 Zulu. Winds are 130 degrees true at 5 knots. Visibility 15 statute miles. Overcast 2,500. Temperature 0 degrees. Dew point -4. Altimeter 3033. The remarks: stratocumulus 8 octas and sea level pressure at 279er. So now we're going to try to decode it and work through it all together. This Metar is from Saskatoon, and you can see it's a lot longer and it looks like it has a lot more information. So we're going to have to learn how to decode all of this, and it's probably not something we'll see more frequently or very often, but it's going to be something we can see or expect one day. So I want to cover all the bases there. So the first part of this whole sequence tells us what type of report it is. In this case, it's a Metar. So Metar is an aerodrome routine meteorological report taken on the hour. So anything that's taken off the hour, so not exactly on the hour, will be indicated by the word specie. Moving on, we have the station identifier. In this case, it's Saskatoon. And all Canadian aerodromes or station identifiers are started with the letter Charlie. So in this case, Charlie Yankee X-ray Echo, or Charlie Yankee Yankee Zulu for Toronto Pearson International, as shown before. And next we have date and time. You'll notice in Metars, we don't actually state the month. So the month is the current month that you're in, and then it's going to be the 29th day at 2000 Zulu. So Zulu is what we call UTC time. So it's the time we use as all pilots, and it's the universal time that we use. Next, we have report modifier. So this is a change or any change in observations as indicated by the letters Charlie Charlie Alpha. So the first change is made, then it'll be listed as Charlie Charlie Alpha, and if there's a second change, it'll be Charlie Charlie Bravo, and so on. So in this case, you can also have the word auto, which indicates that the observation was taken by an AWOS. So listed below, I'll explain what an AWOS is in a description. Next, we have our wind. So this is the surface wind that we're going to encounter. In this case, it says 300 degrees true, so 300 degrees true at 15 knots, gusting to 25 knots. So what this means to us is the wind direction is created based on a 2-minute mean wind direction to the nearest 10 degrees true. And the wind speed is calculated to the nearest knot. And anytime we see anything that says 00000 knots means calm winds. And next we can see that there's a letter Golf associated with the 25 knots. So what that means is peak gust speeds are preceded by the letter Golf. So this is the peak gust speed of 25 knots that it's encountering at Saskatoon. Moving on, we have prevailing visibility, which is 3/4 statute miles. So visibility is always reported in statute miles in Canada here. So you see that Sierra Mike at the end of it. And next we have RVR, which is known as runway visual range. And in this case, it says runway visual range for runway 33 is 4,000 feet with a downward trend. So you can see that it tells you the distance and it tells you the tendency of what's happening. So the important parts are the distance and the last phonetic that we see. So there's 3 options there, which is \uniform, which is an upward trend, and \delta, which is a downward trend, and \November, which means no change. Moving on, we can see this is the present weather that we can see at this specific airport. So in this case, it says light rain and mist. And we can see that the dominant weather phenomenon is always reported first. So you can see dominant weather phenomenon in this case is rain. And you can see in this case, it's associated with the sign negative, which means light rain. If it's had nothing in front of it, it would just say rain. And if there's a plus sign in front of it, it would say heavy rain. And the next part of it, we can see BR doesn't actually associate itself with mist. So how I like to remember this part and a trick that I used was I treated BR as baby rain, and that would trigger me to remember, okay, baby rain is mist. So maybe that technique you can use too to help you learn different precipitations that you might see at specific aerodromes. So next part, we can see this is the Saskatoon's sky condition, which is broken at 800 feet and overcast at 4,000 feet. And this really means nothing to us until we break down what broken, overcast, scattered, few, and sky clear really mean. So we'll first start with sky clear. So Sierra Kilo Charlie. That means no cloud. And if it's an AWOS report, it will report CLR, so clear. And it means no cloud below 25,000 feet. Moving on to the next part, we have few, which is greater than 0 to 2 octaves of cloud. Scattered, 3 to 4 octaves of cloud. Broken, 5 to 7 octaves of cloud. And overcast, 8 octaves of cloud. So you can see if it's 8 octaves of cloud, it means there's full coverage of the sky over the aerodrome at that specific time. And the next part we have is temperature and dew point. So in this case, it's temperature 21 and dew point of 19 degrees. If it's a negative temperature, it's associated with the letter Mike. So Mike 21 or Mike 19, then it'll be minus 21, minus 19 degrees. And the next one is altimeter setting. So altimeter setting is associated with the letter alpha in front of it and it listed by the 4-digit number after it. So you can see in this case, altimeter 2992. And the next one we can see is wind shear. This is actually not seen too often. So it states there's wind shear on runway 33. And what that really means to us is that wind shear was encountered or reported during takeoff or landing phase at 1,500 feet AGL and below. And wind shear information is only reported or will be provided by an aircraft when it's 1,500 feet AGL or below. So it's usually on the takeoff or landing phases that you'll see this. This is something that we won't see very, very often too. So next we have remarks. So this first part of the remarks explains the cloud layers that we see. So the first layer we have is a stratus-fractus layer at 5 octaves, followed by a nimbostratus layer at 3 octaves. Moving on, it can tell us supplementary remarks about the visibility to the northwest of the aerodrome is showing 3/8 statute miles. So definitely not a VFR condition for a pilot today. And the next part we have is sea level pressure. So sea level pressure is usually how we say it or write it down is mean sea level pressure, so MSL. And in this case, it's 1013.4 hectopascals. So sea level pressure is measured in hectopascals. So some points to remember is if the coded mean sea level pressure value starts with a 9, 8, or 7, we add the number 9 in front of it. So an example of 880 sea level pressure, it becomes 988.0 hectopascals. So in our situation, when it's 134 sea level pressure, then we have to add a 10 in front of it. So anything that starts with a value of 0, 1, 2, or 3, we add the number 10. So in our example, it would be 1013.4 hectopascals. And finally, the last part, you just read it straight off. Density altitude is 2,500 feet. And then we're going to move on to a couple of examples that I included in here. What I want you to do is pause the video once you see this METAR, and then I want you to practice saying it once before you actually listen to me saying it. So the first example we have here is METAR for Kitchener-Waterloo. So I want you to pause the video here and then try to do it yourself. So the METAR at Kitchener-Waterloo Airport on the 26th day at 1400 Zulu is an automated weather sequence. Winds are calm, visibility 1/8 of a statute miles, fog, vertical visibility of 300 feet, temperature 7, dew point 7, altimeter 2979er, and remarks sea level pressure of 0, 9, or 7. So in this case, we have to add a 10 in front of it. So it'll be 1009.7 hectopascals. So next we have the Montreal International Airport METAR. So the METAR at Montreal International Airport taken on the 26th day at 1400 Zulu. Winds are 020 degrees at 12 knots, visibility 6 statute miles, mist, overcast 1,100 feet, temperature 1, dew point 1, altimeter 2997, and remarks stratus layer at 8 octaves, and a sea level pressure of 150, which means we add a 10 in front of it, so it'll be 1015.0 hectopascals. So we're going to end off with the Vancouver International Airport METAR. So the METAR at Vancouver International Airport on the 26th day at 1400 Zulu, winds 080 degrees at 5 knots, visibility 20 statute miles, few at 2,800, overcast at 3,900, temperature 6, dew point 5, altimeter 3036. Remarks, stratocumulus of 2 octaves and stratocumulus of 6 octaves. Sea level pressure 282, so we'll have to add a 10 in front of it, so it'll be 1028.2 hectopascals. So hopefully this information was helpful, and hopefully it can help you learn to decode a Metar and be comfortable decoding a Metar. And if you have any concerns or questions, leave them in the comments below, and any suggestions for future videos, just let me know. And I hope that information was helpful for you and help you learn how to decode a Metar.